With all of the considerations we've talked about in mind so far, it's time for a look at the practical applications. In prototype molding, there are also different kinds of casting. I'll discuss solid casting, combination casting, also known as overmolding, hollow rotational casting, and expanding casting. The first type of casting we'll talk about is the most common type, a solid casting. In solid or standard casting, the entire cavity of your mold is filled with one material, resulting in a solid cast component. I recommend solid casting for small to medium parts. If you decide to cast a larger solid, the weight could become an issue and the cost increases. The more material you use, the more expensive it is, so many designs minimize unnecessary bulk. Large volumetric plastic parts made with factory methods found around you are generally hollow with structural design features and consistent wall thickness. These parts would still be considered a solid casting because the mold itself creates a solid vessel, even if it has a complex topography. Combination casting or overmolding is a process of casting a part in more than one cycle, usually combining materials into a single product. The most common example you might know with overmolding is a toothbrush. Handles are often made of 3 or more types of material to create the desired textural combination of soft grip and structural handle. This makes use of the unique characteristics of multiple materials. A specific portion of the part is molded usually with a harder material and cooled. It's then placed in a second mold with bristles and to add the rubberized grip material, which will bond with the final part and becomes one toothbrush. Sometimes, plastic parts are molded over metal inserts, which can be very helpful for electronics. And lastly, overmolding often requires a mechanical method of bonding the two materials together so that it can grip together and bond. Adhesive bonds are useful, but the strongest bond is a combination of chemical bonding and mechanical bonding. Rotational casting, or rotocasting, is a method whereby the mold cavity is filled partially while being rotated, so that the curing or cooling materials fills a near equal layer of material on every surface of the mold. This results in hollow components that maintain their exterior detail and texture, but don't have an exact wall thickness. The material melts, flows, and contacts all parts of the mold at its lowest gravitational point because it's not filled by force. There are limited inherent stresses and can be very strong. Rotational casting is well suited for projects that don't have interior mechanisms or specific project needs for exact wall thicknesses. I didn't name these methods, and they can get a bit confusing. But rotational casting is generally for thermoplastics and involves a heating element where it heats up the plastic and then cools it down. Rotational molding uses thermoset resin materials that combine and cure, doesn't heat up at all, and can be done by hand for short-run projects. Another kind of casting is with the use of expanding foams. Some of them can expand up to 18 times their original volume. In this example, I have a cushion. I'm going to expand this subassembly and then just make this back part transparent. Close that back up. This type of casting has some special considerations for where your inflow will go and how many outflow ports you'll need to design into your project, which are these. Contributing factors like heat and moisture will affect the process, so pay close attention to those factors on your specific material. This method is often used for projects that will have an unseen back face. This is an opportunity to use back pressure and have an open-faced pour. This board is what would be considered back pressure and has these outflow ports here. You need those so that after pouring material, the mold will fill all the way up to the corners before evacuating via the outlets. Foams are also sometimes used to fill hollow rotational molds for things like insulated coolers or flotation devices. I hope this has given you a few ideas for how you can combine casting methods to make the most of your projects. Each method has its own pros and cons, so choose wisely.